Hello, today we are continuing to study chemical formulas and we have now arrived at the next category. This is a category of first and second ionic compounds. First and second group of ionic compounds, which means metals with constant and variable valency, but which are formed by more polyatomic compounds, that is, when more complex ionic non-binary compounds are included in the composition of the ionic compound. All right, let's commence with the first example, shall we? So, if the ionic form is represented as SO3,2, this particular form is referred to as such form is called accordingly. It is denoted in this specific manner, as shown. Hey, check it out, the suffix is going to change. When the suffix sounds exactly like that, it means that in this case, the oxidation state of this particle, which is part of this ion, is in an intermediate oxidation state. Well, for example, let's say it's a connection of sodium in this ion. All right, one more time, we're learning how to put together these formulas with you. Sodium is located in the first group, therefore its charge is +1. Sulfur trioxide has a charge of -2. The cross rule is applicable in this situation. Sodium carbonate. This compound will be named in accordance with its chemical structure. In the first place, we write the name of sodium, and the name of the ion, which forms a polyatomic atom or particle, is called respectively like this, in the following manner or in a similar fashion. You don't need to specify its charge for sodium because otherwise this particle is not called that way. Next, let us proceed to examine the SO4 particle. This particular particle, which was once known as SO4, has now been given a different name. Please pay attention as the suffix ending has been changed to ITI. Let's consider a connection that consists of potassium, which is commonly misspelled as potassium. So, potassium possesses a charge of +1, or you can simply state plus, so 4 possesses a charge of -2. The cross rule applies to potassium and to SO4. In line with the decision, it will be referred to as sulfate accordingly. What's up? This is the following particle. This particle is NO3. The name will sound like this, and the suffix ending is because both here and here the elements of nitrogen and sulfur have the highest degree of oxidation, so let it be a compound associated with iron. And as we understand, iron can have a charge respectively 2+ or 3+. Therefore, the compound formed between iron and the NO3 particle can have a formula of either Fe, NO3, 2, or Fe, NO3, 3. Let there be 3+. So we put a minus here accordingly, then brackets should appear. So you take the formula like this, and according to the rule of the cross, it will look like this. How is it possible that it cannot be done? Please verify it. You were unable to do it in that way. This record would be incorrect because the 3 refers to the entirety of this particle in this location. So in summary, the name of the substance sounds like this. It is iron and, as a result, nitride. This accurately reflects the composition of the substance. The suffix for the ending will be like this. The subsequent particle that follows is PO43. That is the name it is called. As per the corresponding information, phosphate is the correct and appropriate term. Hey, just so you know, the suffix ending will be the same. For instance, let's say it's a connection with calcium, like we discussed earlier. So, calcium has a +2 from the periodic table, and we take a -3 from here. Subsequently, in accordance with the rule of the cross, there is a presence of calcium 3 and PO4 twice. Here it is, the rule of the cross. Once again, we can't just put an index on oxygen like that. Hence, the designated name for this substance will be calcium phosphate, as per its chemical composition and properties that align with the nomenclature conventions in the field of chemistry. Okay, let's proceed to the subsequent particle, O. It is called hydroxide. Please pay attention. Here we have a suffix ending with "id", but in this particular case, it will be an entire word that corresponds to this name. Let us devise a formula to represent sodium hydroxide, a widely used compound also known as caustic soda. Sodium has a positive charge. O group has a negative charge, so it will be like that. Formula is accurate. Then the name will sound like this. Hydroxide, sodium. These are chemical substances used in various applications. All right, here we go. We've put together some examples of substances, and let's practice some more. And now let's do the reverse name, which the task is the opposite. When a name is provided and we generate a formula. All right, let's have a name similar to this. Oh. What is up? All right, as a starting point, we write down the element potassium. Hydroxide signifies clearly the chemical group O. Now let us charge up. It is a plus here. There's a minus here from the periodic table of elements. The formula is accurate. All right then, moving on, let's proceed to analyze the specific type of connection, shall we? Let us designate it as nitrate. Consequently, copper is represented by Cu, because there is a 2 indicating the presence of nitrate. Pay attention, it is No3 with a negative charge. And then, utilizing the cross rule, we express it in the following manner. Q, No3, 2. Great, here's another example. Let's say it is in this form. Q, No3, 2. In this case, Q represents copper, No3 represents nitrate, and the subscript 2 indicates that there are 2 nitrate ions present. This notation is used to accurately depict the composition of chemical compounds and their respective charges. Let it be as ferrous sulfate 2, commonly abbreviated as FeSO42, a widely used compound in various fields and industries. Okay, first things first, let's discuss iron. Once 2 indicates 2 or more than 2. Sulfate is a compound that consists of the chemical formula SO4. So today we managed to come up with names, create formulas, and figured out how to do it with more complex ions with acidic residues. So today we were able to generate names, formulate equations, and determine the process for handling more intricate ions containing acidic residues when there are a total of 2 particles in the composition. How will the name be formed? I hope that in this particular case it also became clear to you and you will do it right. However, that is all for today. Goodbye.